Namaskar, Adab, Shat Sri Akal. So, welcome to the live classes in group theory. Welcome to our YouTube channel. And certainly, we are going to discuss some questions on cyclic groups. And yes, exactly those type of questions that has been asked in CSIR NET or that might be asked in CSIR NET exams. Okay. So in the this is a live class number 10. I would also like to say that on this channel I have already completed real analysis. Okay, but that is in Hindi medium, but no worries, you can understand that easily. Okay, because for mathematics language is never a problem, no matter English or Hindi. Okay, so real analysis has already completed, and I'm trying to complete this algebra portion for CSIR NET, and this course will be equally good for GATE and IRISAM as well. So in the previous lecture we have discussed some beautiful results that might help you to solve today's MCQs. Okay, so the first result was what? If the order of the group is a prime number where P is a prime, then certainly there will be one possibility that G will be isomorphic to P. Another result was this, that if the order of the group Z is P squared, then we may have two possibilities. First possibility is that it will be isomorphic to ZP squared, and another possibility is what? It will be isomorphic to ZP cross ZP. Thereafter, we have also discussed this result, that if order of Z is equals to P into Q, where P is strictly less than Q, and P is not going to divide a Q minus 1, sorry, P is not going to divide Q minus 1, yes, we are right. Then in this case there exists only one possibility, and that possibility is what? Your G, your group will be isomorphic to ZPQ. And yes, one more result was there. These examples have been discussed in the previous lecture. I would also like to say this result was also discussed, that if the order of the group G is equals to P into Q, where P is strictly less than Q, and if P is going to divide this Q minus 1, then there exist two possibilities. Either your group G is isomorphic to ZPQ, or it will be isomorphic to some non-abelian group. And on this we had already discussed some questions, okay, that were asked in CSIR NET. And I would also like to say this session, this live class 10 is going to begin with a question, a HW question, which has been given to you yesterday. And in this question you can see the order of the group is 55 and G has element of order strictly greater than 11. Then what would you like to say? Is your G non-abelian? Is your G abelian but not cyclic? Okay, what would you like to say? Is your Z always cyclic? Okay, so yes, this was the question. So certainly this question is completely based on the results that were discussed in the previous lecture, and we can solve that easily. Okay, so first of all we can see what? The order of the group Z is 55, which can be written as the product of prime 5 and 11. All right, so you can see it is it can be written, 55 can be written as 5 into 11, and we can also observe that this 5 is going to divide 11 minus 1. Isn't it fine? Yes. So according to the previous result, we can say that this G is isomorphic to Z55, and this G is also isomorphic to some non-abelian group of order 55 for sure. Okay, non-abelian group of order 55. Okay, because this result has been discussed in the previous lecture. Yes, you can see that result over here, है ना? Order of G is equals to PQ, P is strictly less than Q, P divides Q minus 1, then there exist two possibilities. Either your G is isomorphic to ZPQ, or your G is isomorphic to some non-abelian group. And here in this case, in this question, you can see the same thing is going to happen. Order of Z is 55, so 55 can be written as 5 into 11, and 5 divides 11 minus 1. So either your group is isomorphic to Z55 or it is isomorphic to some non-abelian group. But here is a condition that gives you the signal to say the right thing. What is the condition? The condition is Z has element of order strictly greater than 11. Okay, so yes, this is the condition that yes, G has the group of order strictly greater than 11. So what the thing is going to happen? We have to use that, and that will let you to conclude that whether your G is isomorphic to this or some non-abelian group. So if the order of Z is 55, then possible order of elements are certainly 1, 5, 11 and 55. Okay, these are the possible orders. Given G has element of order 11, given G has elements of order greater than 11. Okay, so certainly greater than 11. So we can say what? G has elements of order 55 also, isn't it? So G has elements of order 55 also. This has been concluded from this statement. Okay, G has elements of order strictly greater than 11. This concludes what? G has elements of order 55 also. And if G has elements of order 55, then we will not hesitate to say that G is cyclic, isn't it? Yes. So that's why the conclusion is what? G is always cyclic. So that condition matters. Once again, I am going to ask another question of CSIR NET type. Okay. So yes, what the question is, let me write it first and thereafter you should try. Let Z is a non-abelian group. G is a non-abelian group of order 8. Okay, G is a non-abelian group of order 8 and G has exactly one element of order 2, and G has exactly one element of order 2. Okay, G has exactly one element of order 2. Then what would you like to say? Yes, option A is what? G has elements of order 8. G has elements of order 8. This is option A. Option B is what? G has 5 elements of order 4. G has 5 elements of order 4. Okay, option C is what? G has 6 elements. G has 6 elements of order 4. Okay, and option D is what? G has 2 elements. G has 2 elements of order 2. Okay, yes, these are the things. Let G is a non-abelian group of order 8 and G has exactly one element of order 2. Then G has elements of order 8. This is option A. G has 5 elements of order 4. G has 5 elements of order 4. This is option B. G has 6 elements of order 4. This is option C. And G has 2 elements of order 2. Okay. So here we have 4 options and you just need to say the right thing. So first of all, if you have a group of order 8, then what are the possibilities? Okay, because this group has order 8, so there is a possibility that this G will be isomorphic to Z8. This might be a possibility because order is 8. Another possibility is what? It might be isomorphic to Z2 cross Z4, isn't it? Yes. Another possibility is what? It might be isomorphic to Z2 cross Z2 cross Z2. Yes. Okay. Thereafter, we can say what? It might be isomorphic to D4, or it might be isomorphic to Q4, quaternion. Okay. So these are the groups of order 8, isn't it? This D4, Q4, Z8, Z2 cross Z4, and Z2 cross Z2 cross Z2. All these groups are of order 8. Okay. And this G might be isomorphic to any of these 5 groups, either isomorphic to Z2 cross Z2 cross Z2, or maybe isomorphic to Z2 cross Z8, or maybe isomorphic to Z8, maybe isomorphic to D4, or maybe isomorphic to Q4. But one thing is given in the question, that Z is non-abelian. It is given in the question that Z is what? Non-abelian. And its order is 8, and exactly one element of order 2. This is also the conditions. So these conditions will give you the link to say the fact the group is isomorphic to exactly which group. Okay, so we must have to focus on these conditions, because these conditions will let you to say the right thing. Okay, so the first condition is what? Z is non-abelian. So first of all, as per the condition, you know this it is cyclic. This Z2 cross Z4 is abelian. These are abelian groups. Okay, but as per the condition, your G is non-abelian. Therefore, certainly this G is not isomorphic to Z8, not isomorphic to Z2 cross Z4, and not isomorphic to Z2 cross Z2 cross Z2. So we have only 2 options remaining. Either your Z might be isomorphic to D4, or your Z may be isomorphic to Q4. So now, if our G is isomorphic to D4, then G has 5 elements. G has 5 elements of order 2. Okay, because this D4 is over here, and D4 is what? Even. So for Dn, if n is even, then n plus 1 number of elements will be of order 2. We have already discussed it. So D4 is over here, so certainly it will have 5 elements of order 2. It will have 5 elements of order 2. Okay, this G has 5 elements of order 2, but here in the question, what the thing were there? Exactly 1 element of order 2 is there. Okay, but we know D4 has 5 elements of order 2, and that's why this G is not isomorphic to D4 as well. So what the thing is remaining? Certainly your G is isomorphic to Q4 only, isn't it? And Q4 has no elements of order 8. Okay, and Q4 has no elements of order 8 and 6 elements of order 4. And क्योंकि plus minus iota, plus minus j, plus minus k, okay, plus minus 1. These 8 elements are there in Q4. So it has no elements of order 8. No elements of order 8 in Q4. We know 6 elements of order 4, plus minus I, plus minus j, plus minus k. These 6 elements will have order 4. 6 elements of order 4. Exactly 1 element has order 2. What is that? Minus 1, isn't it? And in the question also, it was given that exactly 1 element has order 2. So minus 1 is that element, and 1 has order 1. So certainly our G is isomorphic to what? Q4. And Q4. So we shall say what? What will be the right answer? G has 6 elements of order 4. Yes, it's right. Elements of order 8 is not possible because our G is isomorphic to Q4. G has 5 elements of order 4 is also not possible. Okay, because 6 elements have order 4, so that's why this option B is wrong. Z has 2 elements of order 2 is also wrong, because plus 1 will have order 1, minus 1 will have order 2, and rest all the 6 elements will have order 4. So that's the reason we shall say what? Yes, we shall say Q4 was the group and G was isomorphic to Q4. Option C is the right answer. Now I am going to ask another similar questions. Yes, another question, and this kind of questions used to ask in CSIR NET. So if order of Z is 35, if order of Z is 35, then option A is what? If Z is abelian but did not be cyclic. G is abelian but need not be cyclic. Option B is what? G is non-abelian. G is non-abelian. Option C, G is always cyclic. G is always cyclic. And option D is what? G has no elements of order. G has no elements of order greater than 7. Okay, so yes, 4 options are over here, and once again you can see that the order of the group G is what? 35. This 35 can be written as 5 into 7. So which condition is here? So here P is 5, Q is 7, and certainly this 5 is not going to divide 7 minus 1. So unique possibility will be there or not? Yes, unique possibility will be there, because order of Z is P into Q and P is not going to divide 7 minus 1. What does it means? According to the previous result that has been discussed already, your G is isomorphic to what? Z35, and Z35 is cyclic for sure, and therefore what shall we say? G is always cyclic. So that's why option C is the right answer. Okay, so I would like to say in the next class we will certainly discuss the Lagrange's theorem. Okay, we will discuss the Lagrange's theorem, all the consequences, problems and things related to it. So certainly we will also introduce you with the cosets. Okay, and certainly left cosets, right cosets. We will discuss how can we count the number of cosets and how can we apply Lagrange's theorem to find the number of subgroups or number of cyclic subgroups and things related to that. So we'll see you tomorrow at 8:30 p.m. Till then, take care. Bye bye. Good night. Thank you.